tricky here. I'm just using my good old pi r squared, and I'm going to put the radius in there, which in this one is 8. And let's be honest, when I punch that into the calculator, I usually, just to make it easy, I do 64 pi. Because I know 8 squared. Why am I punching in 8 squared? But punch in whatever you need. We're going to round to 2 decimal places because the directions say the hundredth. Final answer. What do you got?
201.06.
Perfect. And I'm going to label. You know I love to label. Area, we are squared. Centimeters squared.
Do I have to put the 0.06?
It says to the hundredth, so yes. Yeah, I know. Okay, next one. Only difference is, just to practice, this is really our calculator skill practice, to make sure we can put a fraction in the calculator. The setup's the same, pi r squared. Now here's my pro hint for you. I think, personally, that you can do whatever you want, and I'll show you. I think it's easier to make this improper. That would be 3 times 1, 3, plus 1, 4. I think it's easier to use 4/3. But I'm going to show you, let me pull up the calculator. You can do it, obviously, both styles here. So don't forget, if you hit alpha y equals, it pulls up this fraction menu for you. Number 2 sets it up so you can type in 1 1/3. I just personally think that's obnoxious. I'm going to use the 4/3. So I'm going to do pi. I'm going to do parenthesis. Now, you could do the fraction operation so it looks exactly like what is displayed. 4, 3, don't mind my slow typing, squared, got it. Or, I'm usually too lazy even for that, because we know, what does a fraction bar mean? What operation? Divide. So I just do 4 divided by 3, especially since I can give a decimal. And you get the same thing, okay? So it's just a little calculator review. Round to the hundredth, so I'm going to put 5.59 for that guy. And I know these are a little different ordered than what's on your notes. Just kind of an organization thing. Because I knew I needed a little room for 3 here. Okay, circumference. Now, remember, we're after area. So I'm like, what am I doing here? Area, pi r squared. We need the radius. Radius. So they give you circumference. The formula with radius and circumference is the 2 pi r. So I'm going to use that form, not pi d, because I need radius for area. Now they tell you the circumference 4 pi. I'm hoping some of you can just mental math it and figure out what your radius would be. 8. I heard 8, I heard 2. 2. 2 pi times 2 is 4 pi. Or do the inverse operations and get fancy here. So we get radius of 2. Okay, now that's not my answer though. Remember, the directions ask you for the area. Well, I can give you that now. If the radius is 2, big deal. I'm going to do my pi r squared with 2. So punch in your calculator 4 pi, I would go with. What do you got for that one?
12.57.
You got it.
The circumference and the area the same?
Say that again.
Are the circumference and the area the same?
No, different. Circumference, remember, is that distance around the edge. Area is all of it on the face of it. If you shade in a circle, that's the area.
But if you do, yeah, they're both 4 pi. Because if you put 4
Hang
pi.
on. Let me finish labeling this. I'm ready, Haley. Say it again.
Okay, so I put pi 2 squared. It equals 12.56.
Say that again. You did what squared?
Pi 2. Wait. I'm so sorry. I did pi times 2 squared.
Okay. Yep.
Which is the same as pi 4 times 4.
Right, because 2 squared is 4.
Well, then, okay, never mind.
Okay, all right. I just want to make sure I answered. All right, last problem, a little algebra review, because this skill comes up in like one of our circle problems today. But I know you know it. How do you get rid of squaring?
Square root.
Okay. So see if you can type that in, the square root of 100 over pi. I'm happy to type it in for you, but you try it first. Because I feel like half the battle is being good with your calculator. I like it. So Anna said 5.64. And I'm going to add one more thing to that before I circle it. Squared. You should have how many answers? 2. So what am I going to throw in front of 5.64? Plus or minus. A little algebra review for you. Any questions how to type that in the calculator to get the 5.64? Nothing? Okay. So area today is going to be pretty dang easy. It's kind of what we did in 1 and 2. Although, ooh, they might give you the diameter instead of the radius. Ooh, okay, not that that's going to be crazy. And then we're going to get into this area of a sector. Now, unfortunately, the notes are not my favorite because the copy machines did not copy some of the shaded regions very well on these. Save on your homework. So be ready to pay attention and shade some stuff in that the copy machines didn't help our cause with very much. Make sure that you wrote down on here the formula for area of a circle, pi r squared. Make sure you have that filled in on the blank. Again, you will get a formula sheet though for any quiz, next week's quiz, and when we get to the test. Not that you have to have it memorized, but you probably want it on front of your notes. Okay, easy problems. We're going to do 2 more area problems, and then we'll get into the sectors. Now, notice directions. Find the area of the circle in terms of pi and to the 10th. Same on your homework. They're going to ask you for the exact answer with pi, then they want you to punch in the calculator and round it. Okay, fine. So, same formula, pi r squared. They give you the radius. So the first thing I'm going to do for my first exact answer, the only thing I'm going to do, or I should say you're going to do, punch in your calculator, what's 2.5 squared?
6.25.
6.25. So my exact answer is 6.25 pi. And you know I love a label, centimeter squared. So that is the exact answer. Now, and same on your homework, they're going to ask you for an approximated answer where you punch this in, punch pi in, and give me the decimal form of that. So what's 6.25 times pi? You can round to the 10th.
19.63.
Like it. So don't let the directions throw you off. I'm telling you right now, the first 3 on the homework, it's the same thing. They want the exact answer with the pi, then punch it in. Whatever, that's fine. Ooh, here's the real trickster of the day. Feel my sarcasm. If the diameter is 6, what's the radius? 3, okay. So we're going to do pi times 3 squared. Or what's your perfect exact answer? 9 pi. 3 squared is 9, 9 pi. I'm going to label. You know I love a label. And then you're going to type in your calculator 9 pi. Round to the 10th, what do you got?
28.3.
Okay. Got it. So the next thing that we're going to get into, which is new for you, but again, you're going to get the formula here and whatnot. We're going to start talking about this area of a sector. Now, first we got to talk about, well, what the heck is a sector? So let's get into that.
Part of the area.
So part of the circle, yes. So a sector, I would write on your notes what's in red up there. The region bounded by 2 radii of the circle and their intercepted arc. That is a very formal, long definition. I think of it as it's a piece of pizza, a piece of the pie. Go for pie right now.
What kind of pie?
French silk.
I want pumpkin pie.
Ugh.
Pumpkin or sweet potato.
What's wrong with pumpkin pie?
I'm not a big pumpkin pie fan, kids. Just-
You have to
What
have
about
it when
blueberry
you cool
pie?
it.
Oh boy. Ooh. Okay, if you like it, you like it. You do you, kids. So remember, my dramatic drawings, you don't have to draw this. So the area of a circle is the whole thing. Pi r squared is the entire area. Now, I don't think this copied very well. This should be shaded. I don't think the shading happened very well. Of course, when you were just doing a piece of the circle, a wedge, whatever you want to call it, that is the sector. And of course, I see some of you already writing. Here's the formula. Jot that down. We're going to talk about it. And again, you'll be provided that. So don't ever think you got to memorize them. Make sure you got your formula down. Now, if you look at the formula, it's kind of similar. It's kind of that pink color here on the board. It's kind of similar to the arc length. Notice the right sides are the exact same. Remember, these are fractions because we're only looking at a piece of the circle versus the entire circle. So arc length was a piece of the circumference, the piece of the edge. You compared it to the circumference. A sector, piece of the pie, we are comparing to the overall area of the entire circle. And then of course the angles are the same thing. You know a full circle is 360. We'll look at our central angle. So that is the formula. You'll get that on your quiz. You don't have to have it memorized, but it's always good to know. Now, I don't think the shading copied at all on this. Clearly there's no red or blue. We need color copy machines. So try to at least label red, blue. I don't care if you do some crazy shading or whatever, but I'm going to start with the red sector. So I'm going to start with this one. So try to, I know, I'm sorry, the copies aren't that great. Gabby, Kylie, focus here, my friends. Doing some new stuff, you've never seen it. Now, formula is very similar to the arc length. The right side doesn't change. This 360 is always 360. Again, mine's in color, yours in the, I'm doing the red sector. Its angle is 70. Now, we are finding the area of that sector. So I'm not going to write area of the sector. I'm just going to put a variable for it. Let's just say x. That's what we're after. And we're comparing that to the area of the entire circle. Well, humor me. What's the radius on the circle? And I know we're going to be very shocked when I say we're going to use cross products, just like we were doing for arc length. Some of you don't have to write anything else down. You're just all on your calculator, which is fine. So first I would do the more complicated diagonal. So punch in your calculator 70 pi, 8 squared, 64. I can do that. And then of course we're going to equal our other diagonal 360 times x. And you know you have to divide off 360. All right, it does not tell you what to round to. I rounded to the 10th. That's a sloppy x. See what you get, punch it in, because half the battle's using your calculator. 39.1 we should get. Punch it in, make sure you can get the 39.1. And I'm going to label, I'm going to label. What am I labeling?
Squared.
Does it tell you, here's a hint. Does it tell you what the specific units are?
No.
So we're going to use, for a label, unit squared. I like the label. Okay, then we got to do the blue. Well, okay, all right, I'm on it. We got it. Little question for you though. They don't specifically have it laid out what the angle is for the blue sector, but we can find it because a full circle is how many degrees?
360.
And if the red was 70, what's your blue? 290. So the only thing that's going to change in my step here, I'm going to replace the 70 with 290. Because I'm finding the area of the blue sector, I'm comparing it to the area of the whole circle, we changed it to 290, so that's the only thing that changed. So again, cross products, I always just out of habit start with the more difficult one, 8 squared, so and of course divide off your 360. I rounded this one to the whole. What do you got? 162. Units squared. Okay, one last thing on this one. Because, I always got a little pro tip for you. There's another way you could have gotten that blue sector. And I can't say one's way easier than another, but just to talk about it. The other way you could do it, let's say you got the red one already. You know the red's 39.1. You calculated that out. To do the blue, I could have done the area of the entire circle. So that would be the whole thing. And how could I just get the blue piece now? Subtract off the red. That gives you 162. Do I care how you do it? Nope, sure don't. It's whatever you want to do. So you could do the area of the entire circle and take out the red wedge, the red piece, and that leaves it with the blue. Or do your formula. I don't care, whatever, okay? You decide. So again, I don't think this copied very well. So, because it's going to talk about red and blue again, so just maybe label R and B for them. This is where we really need color copy machines. Okay, use the diagram to find the indicated measure. First up, area of the circle. The entire circle. So what formula are you using? Pi r squared, yes, pi r squared. What's the radius on it? 14. Punch that in for me, and I rounded to the 10th. What do you got? I'm going to label. Okay, now I'm going to do the red. Now I've got to do the crazy fractions formula for the piece of the circle. I'm going to set it up. This is always 360. Let's start with the easy thing. What's the angle on your red sector? 120. We're going to find the area of that. That's what I'm looking for. Now, you have a choice here. Of course, pi r squared, you could put pi times 14 squared, or don't we already know what pi times 14 squared is? You could put 615.8 there. Do I care? No, you'll get the same thing. Whatever. Do your cross products, get me the red sector. Give everybody a chance to type. Sound of calculator keys is like spa music to me. Isn't it soothing? All right, punch it in. You should get, are we ready? 205.3. How'd we do? And again, I'm happy to type it in. Now, I can't believe these words are going to come out of my mouth. Lord. Try to get the answer for the blue sector with the least amount of work you possibly could do. Maybe some of you aren't even going to write down work. You know the area of the whole circle. You know the area of the red. I like it. How are you going to get the blue with real, honestly, I don't know if I'd even write anything. I'd just be on my calculator. What are you punching into your calculator? What are you doing? You're subtracting them. You're taking the area of the entire circle and you're deducting the red, and that's going to leave you with the blue. So what is your area of your blue sector?
14.
You got it. Love it. Now, could have you set up the formula, found the area, the angle to this, which would be 240, swap that to 240, do it? Yeah, you can. I don't care. You'll get the same thing. But remember our motto, we're going to work smarter, not harder. All right, couple more area problems with some shaded regions, some different things. Let's try to work smarter, not harder, right? I think this one, the shading's okay on your notes. I was peeking to look. Two congruent white circles fit into this gray circle. What's the area of the gray region? Whew. So these gray pieces, which look kind of bizarro, is what we're after finding the area of. So we're going to work smarter, not harder. Probably an easy way to get them, I could do the area of the whole circle and then do what with the whites? Subtract them, punch them out, get them out of there. That's going to leave you with the gray. So let's first do the area of the whole circle. So I'm using my pi r squared. Now take a second and think about this. What's the radius for the entire circle? So the big circle, I'm talking center to the edge. That would be 6. Because of course this little guy, they're the same 3 and 3. So the radius of the whole circle is 6. So you have 36 pi. You can punch that in your calculator. Depends how ambitious you're feeling right now. It doesn't matter. I'm just going to leave it for now. Okay. We need the area of the little white circles. So I'm going to do that guy. Area of the white circles. Again, pi r squared. Look at the picture. What's the radius of just one of the white circles? 3. So pi times 3 squared, or 9 pi. But hold on to your hats. How many of those little white circles do you have?
2.
2. Okay, final answer. To get just those weird looking gray pieces, I'm going to do the area of the whole circle and subtract out the white circles. So of course you're going to get 18 pi there. That would be exact. You could leave it. I don't care. It doesn't say what to round to. Let's throw it just to practice into our calculator. What's 18 pi exist? You got it. And I'm going to round it. Where are we in meters? Label. There we go. And you could leave 18 pi too. It didn't say if it wanted decimal or exact, so clearly I would take either. So any questions on that? Okay, final two. I don't think the shading's great on your notes for either of them. It's pretty faint up here. Can you see like that's green? So you might want to kind of shade that. I apologize for those not copying the best. Just for the record. All right, area of the circle. I'm like, yes, I'm on it. Area of the circle, pi r squared, all day long. Look at your circle. What's the radius? Let's do it. Come on. You know the radius of the circle? Yeah, okay, so we can't use this. So we're not going to panic. So I'm thinking about where else is that pi r squared formula? In the sector formula. So I'm going to have to get creative and go through that route. Okay, I can do it. Now, of course, 360 never changes. Mine's green, of course, yours is not. But the green one, I need the angle for the green sector. So if the white angle's 50, what's the green one? 310, because we got a total to 360. Now, this is the part we got to be careful on how we fill this in. Is this the area of the sector or the area of the circle? Is it going top or bottom? Top. It's the sector. It's the wedge. We are finding the area of the circle. Pi r squared is the area of the circle. We have to solve for A and we'll be done. So I'm going to use my cross products. So 56.87 times 360. 310 times A. And of course divide off the 310. I know, most of you are just doing this all on your calculator, fine. All right, punch that in for me. Round to whatever, I don't know. 66 you should get. So I don't even want to say this is tricky, but this is as wild as it's going to get today. Watch your angle closely. They might give you the area, the angle of the other sector, and you're going to have to do a little 360 minus it. Not that that's a big deal, but just look close at those angles. Final problem of the day, my friends. Find the radius of the circle. So of course the question is, what formula am I using? Because this has radius, pi r squared radius, so does this one. So I'm like, look at what they give you. They tell you, and I don't think it's shaded the best on yours, they tell you this is 12.36. They give you a sector. So we have to use the sector formula. Okay. So I'm going to set it up, of course, bottom right's always 360. That's the easiest. Now, this is nice, because the angle on my sector that they gave you, they give it to you, 89. So the next question is, where are you putting the 12.36, on the top or the bottom? The top, that's the area of the sector. Now, they want you to find the radius. So last time I just put A for the area for that, but this time they're a little more specific. They want the radius, so I'm going to go ahead, instead of A, I'm going to put the pi r squared in there. And we're going to have to get that r by itself at some point. Now, and I'm going to help you with some calculator tips too. Of course, I'm going to do this diagonal. That's easy to punch in. And then our other diagonal, we've got 89 pi r squared. Holy cow. Now, we're going to solve for r eventually. So the first thing I would do is get rid of the 89 pi. How are you getting rid of the 89 pi?
Divided.
You know it. So, and I'm going to punch it in just to show you to make sure we got it under control. Remember when you were dividing by two things, 89 and the pi? Put parentheses around that. So let me pull up the calculator. So I'm going to do the 12.36 times 360 first. 12.36 times 360. Enter, come on. Divided by, parentheses, 89 pi. Okay, now, so I've got that, whatever. That's what r squared is. I'm going to do this all in my calculator, because you know what you told me earlier today. What cancels squaring?
Square root.
Okay, so watch this. So I'm going to do square root. Now, I'm old, I'm tired, I'm too lazy to type in 15.91403. If you hit second and the negative key, that pulls up your previous answer for you. That automatically cut and paste the 15.9140637 in there. I don't have to type it. Got it. So I'm going to say my radius, let's just round that to 4 meters. So again, I don't expect a lot of work for all of this because I know you can do it in your calculator. Now, before I give you your homework, and I'm going to show it to you, on your homework, because of course, it did not, some of the shadings copy the best. Don't forget on Google Classroom, I always put the PDF of the Word, the original one. Like you're going to see when I give you your homework, these did not shade very well at all, let's be honest. Neither did those. So if you're ever home and you're like, holy cow, like I don't know what the shaded part is because my copies are not great today, always get on there and it will show it to you. So let me